Exoplanet Vision 2050. Hi, Celeste. Is there any hope for us to draw a plausible picture of the future of exoplanet research? Sure, there's a plausible picture of the future, but it's not with outdated theory, that's for sure. For those that don't know who Einstein was, he's kind of a smart dude. He said, it is the theory which decides what we can observe. And it's very important to understand that. It's not that these astronomers that, they're having a hard time finding these objects that are light years away. Because sure, yeah, they're having a hard time finding them. But it's not just that. What it also is they don't have a theory that can explain what those things are. And if they had a theory that it could explain what those things are, they would realize when they're young that they shine with a really, really bright spectrum. And the problem is that the theory doesn't allow them to be classified as this smaller object that's hard to find. You see, they separate the two in their minds. Their theory doesn't work. And let me do a dramatization here for you guys. This is a graph, the Walensky-Taylor diagram. Barrington made this excellent graph for me. And the thing about it is you have stars that are young up here, really massive, really bright, really hot, and they cool and shrink, and eventually they reach a point where they no longer shine. And then you have these objects down here which no longer shine that are classified as planets and exoplanets. So essentially what astronomers are doing is instead of having all of it together in one large cohesive picture, a theory that works, what they do is this. Or I have more of these printouts. They say, well, we have to explain all these objects over here, and then these objects are independent of these objects. And not only that, but they don't even have these objects as being evolutionary in nature, one begetting the other. What they also do is this. They just they do a little slicing. They say all these objects are the same, they don't evolve into other objects. They say all the gray dwarfs were gray dwarfs forever. I don't think they even have a classification of gray dwarf. I don't think they've made the connection between Jupiter and Neptune's stages of objects. They go like this. This is another different type of object. And then you'll see in this other paper, they're saying that the next Nobel Prize should go to the first person who discovers an exomoon, which is a moon in another star system. But as you'll see here, small planets and moons, what they're going to do here is they're going to pigeonhole that as well. They're going to go like this. Oh, the Nobel Prize goes to this person over here. And now the Nobel Prize goes to the first person that discovered this little area right here. But really, that little area is an earlier version of this area up here, which is a later version, which is a later version of this, which is a later version of this, and then the very earliest portion I lost. But anyways, the earliest portion is the portion that shines with a really bright spectrum. Hopefully my dramatization of that is good enough. It kind of sucks. But here's the youngest version. And they don't have these as being exoplanets in their minds. They classify these as giant fusion reactors that are independent of the object that we're standing on, the very Earth itself. And the Earth, from the people who understand this theory, is a 4.5 billion year old star. One should wonder, why is the Earth 4.5 billion years old? If it formed in 1 million or 10 million years, why is it 4.5 billion years old? It doesn't make any sense. And the problem with it is that it's 4.5 billion years old, because that's as long as it took to form. I'm 35 years old. That's how long it took me to form in my current state. It isn't I'm born and I'm a 35-year-old man cussing and swearing and running a business. What? As a baby? No. It takes time for stuff to happen. The astronomers, when they look at the exoplanets, they don't look at them as being evolutionary in nature. They look at them as have been formed as is. And then they're going to perpetually stay as is. They don't evolve at all. But that's completely bogus. That's 1900s. That's 20th century dogma. And we can see this 20th century dogma inside Exoplanet Vision 2050. I'll read that out to you in a second. As well as you see it, and world-class researchers like Sarah Seeger. Sarah Seeger, her main research goal is to find and identify another Earth, including the search for signs of life by way of biosignature gases. Well, Sarah, to find and identify another Earth, you've already done that. The question isn't whether you can find and identify another Earth. That isn't the question you're asking, because that question's already been answered. All the stars that shine in the night sky that are young have the potential to become Earths. Well, basically, those are very, very young Earths. Every single one of them, hundreds of billions of them in our galaxy. So the question is whether or not we can find another Earth isn't the real question. The question is, can we find an Earth in a similar stage of evolution as the Earth is now? And that's similar to saying, well, say you go into a forest and it's full of sapling apple trees. And you go out there and you say, well, it isn't a real apple tree until it has apples growing on it. No, they're all sapling apple trees. Just because they don't have apples growing on it now, like during their current growth season, doesn't mean that they're never going to grow apples. But that's the way astronomers look at stars. They look at stars and they say, well, they don't, they're not hospitable to life. They're not similar to the Earth. They're too hot. They're too big. They're not looking at them as being the young planets. And because it's their theory that they use that blocks their mind. They have the young ones separated from the old ones. They have adult human beings separated from babies. And they look at the babies and say, well, we have these theories about how babies grow and evolve, but these adult men and women over here, we don't know how those even formed. Well, clearly, they were babies at one point. It's the same thing with stars and planets. The stars are the babies and the planets are the adults. It's very, very simple. These researchers, they have this worldview in their heads that's just completely bogus. And we also see it in Exoplanet Vision 2050. Now, the reason why this paper was written is because they say, well, okay, here's a graph here. I want to show you this graph. Now, basically what this is they take the first exoplanet discovery back in 1990 or 1989, and they follow it up with an exponential graph, and they go by decades. So 1990 to 2000, 2010, 2020, 2030. And then they go up on the y-axis as the cumulative exoplanet count. And that's where it goes up logarithmically. So you have 10, 100, 1,000, 10,000, 100,000. And the red we haven't got there yet, supposedly, in their eyes. And they're saying that it's going to be about 100 million exoplanets discovered by 2050. And they're also trying to find out what that era is. So they have the radial velocity era, which is right here. They have the transient era, they have astrometry, and the transient era, and then their question mark era right here. Radial velocity, for those that don't know, all that is you have two objects orbiting each other, and one object pulls on the center object, and that center object wobbles. And when that center object wobbles from it being pulled back and forth by another orbiting object, the light curve on it blue shifts and red shifts. So it goes back and forth. And you can determine if there's a large object in orbit around it by its red shift or blue shift in the center of that star system. So that's the first way we discovered that there's objects orbiting younger stars. And then it goes up to the transit era. And transit is when an object passes in front of the field, in front of the star itself, making the star dim. So we measure the dimming of the object passing in front of it, kind of like a bug flying in front of a car headlight. The car headlight will dim very, very little bit, but then when the bug passes by the car headlight will still be bright. But I mean, it makes a very, 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 very little dip in light, and that's what we measure. And then transit and astrometry is just the motion of the stars and transit. And to go back to the theory determines what you can see. With stellar metamorphosis, we have a better theory. We now can see all the young, hot exoplanets, meaning the count of exoplanets is far beyond 100 million right now. It's around 300 billion inside of our galaxy. And then when we look at other galaxies, the young hot exoplanets called stars in those galaxies are observable as well. And they can be estimated based off the size of the galaxy. So the Andromeda galaxy is a little bit larger than us. That's the next large spiral galaxy that's close to us. That I think that has around 500 billion young exoplanets in it, estimated. So you take the Milky Way, which is our galaxy, and then you have the Andromeda galaxy, and you take the Pinwheel galaxy. I think the Pinwheel galaxy is a little bit smaller. I think it has like 150 billion young exoplanets, and then you take another few galaxies, and before you know it, boom, you have 1 trillion observable exoplanets, mislabeled stars by the astronomers. So basically, when you look at the galaxies and you have stellar metamorphosis to work with, you have a much more complete understanding of what it is you're observing. But right now, what's happening is these astronomers, what they're doing, and it even says it in this, where is it? I highlighted it. It says future topics. More is not necessarily better. And what they mean is they're trying to understand what it is they're observing. And they're saying, well, if we discover more and more and more and more and more, and we have all this data coming in, and we have no way of making sense of any of it, what's the use of discovering more if we can't make any sense of it? The value of it is diminished considerably. It's like going to McDonald's, ordering a cheeseburger, and then you get a cheeseburger, and you're, okay, I need one more or two more, and then you get 2 more cheeseburgers, and then that's enough. 3 cheeseburgers is enough, and a little bit of Coke or whatever. But if you go up to the counter again and you get another cheeseburger, like a 4th or 5th cheeseburger, and you try to down those, it's going to be hard. Or a 6th or 7th or 8th. And the economics term is is diminishing marginal utility. The value you place on those additional cheeseburgers is diminished considerably. And to the point to where, you were in some, cell and you were being tortured with food, and they were shoving cheeseburgers down your mouth, and once you got to the 10th or 11th cheeseburger, it'd be torture trying to eat all those cheeseburgers. The marginal utility would be in the negatives for that one. And similar with what they claim is more actually better, because they can't make sense of what they have right now. They don't understand what it is they're looking at right now. So if there's more of what they can't understand, what they admittedly can't understand, then what's the use? And that signals to me that they're not just looking for data, okay? What they should be looking for is a better theory. But they reject the better theory based off of what's that one word called? I can't remember what that one's was called, but they reject an idea based off of their previously held ideas. Like that saying, you can't fill a cup when it's already full. That's what's happening to astronomers right now, is that when they're going to graduate school, they're learning about how everything works, how it's all perfect. You have to abide by the paradigm and work inside of a box. And if you step outside that box, well, you're just not going to have a career. You're not going to have a job. So naturally, if you have an idea that's outside of that box and it's correct, well, you're not going to have a job, for one. Two, you're not going to ever get your work published. Three, the field isn't going to progress any, because they're obsessed about being correct all the time. And they're not looking outside of themselves for the answers to their problems. It's more or less like a clique. The astronomers, they have a little clique of people that they accept as being valid researchers about. They have their own little worldview, and anything that steps outside of that worldview, they reject them. But I don't want to talk about that. But basically, what this means is, it's not just that their technology is going to increase, that they're going to find more and more of these objects. What's going to happen is, I would say, probably from my perspective, about 2025, about 5 years from now, they're going to finally realize what I've been telling you guys this entire time. Is that the fundamental ideas of astronomy that were accepted pre-21st century were misguided. The idea that stars are fusion reactors, totally false. The idea that, the entire universe was the size of a watermelon, which then exploded for no reason, totally nonsense. And we're kind of moving past that and getting more of a feel of what all this really is. And I would suppose 2025 is when they're going to finally be like, crap, we can't make sense of all this data. There has to be an overreaching theory that can explain this. And that's what I'm providing. I'm providing the theory. But I think I made this talk long enough. Yeah, but basically, that's what it is. And it takes time for stuff like this to happen. Baz, the main paper number 322, it has 1,648 unique IP downloads. That's a lot of eyeballs, just thought you'd like to know. All right, I'll link this paper to the bottom of the page. All right, I'll take it easy.